Hello students, in this week's video we're going to do trigonometric functions. I'll be providing some concepts on how to find the reference angle, the special angles, and ASTC. So if you'd like to know what ASTC represent, please stay to the end of the video. And you'll be doing some questions from assignment 10.1 as well. Right, let's start off by making friends with some basic concepts. So let's start off by having a unit circle. A unit circle is one where we let the radius of the circle be 1 unit. Right, so from the diagram, we can see that the x and the y-axis have divided the circle into 4 quadrants. So between 0 degrees to 90 degrees, that is considered the first quadrant. And between 90 degrees to 180 degrees, that is considered the second quadrant. And between 180 to 270 degrees, that will be your third quadrant. And finally, from 270 to 360, that will be your fourth quadrant. Alright. Now, what we're going to do is we're going to assume that you are a point P and you are actually traveling on the circumference of the circle. And imagine that you start off from the x-axis where the angle is 0 degrees, and then you travel. That means you start off from here where the angle is 0 degrees, and then you travel to this point here. And what happens is that you will make an angle theta with the x-axis. And this theta is positive. Right, so in other words, if you actually traveled from the x-axis in an anti-clockwise direction meaning this direction, then the angle that you made with the x-axis will be a positive angle. Alright, so now what happens if you travel in the clockwise direction? Then what will happen? So we are still on the unit circle, meaning the radius of the circle is 1 unit. But in this case here, you are traveling in a clockwise direction. So the clockwise direction will be in this direction. So if you traveled from the x-axis in a clockwise direction, then the angle that you made with the x-axis will be a negative angle. However, how you define the quadrants will still be the same, as in whether if you travel in an anti-clockwise or a clockwise direction, the first quadrants will still be whatever I've shown you on the screen. The second quadrant will remain the same, third will remain the same, and fourth will remain the same. So let's summarize. So if you're traveling from the x-axis in an anti-clockwise direction, you are in a positive angle. If you travel from the x-axis in an anti-clockwise direction, in the clockwise direction, then you are a negative angle. Right, so we have learned how to measure angle. A positive meaning from the anti-clockwise direction, negative from the clockwise direction. The next thing is there are some angles that we need to make friends with. and there are special angles such as 30 degrees, 45 degrees, and 60 degrees. Okay, why are these angles special? These angles are special because the Trigo ratio of these angles will give you an exact value. What do I mean by saying that? Try pressing sine 30 using your calculator, and you'll see that you get the value half, which is the exact value. Try sine 29, and you'll see that you have a lot of decimal places on the calculator panel. Sine 49, or some other values other than 30, 45, and 60, you will see that what you get are all irrational number. Right, so only these three angles, 30, 45, 60, the Trigo ratio of these three angles will give you an exact value. So we're going to find out what these exact values are. So we're going to use a right angle triangle and also our Trigo ratio to find out. So we're going to start off by having a right angle triangle, and we use 30 degrees because sine 30 gives us half. So that is our starting point. So the Trigo ratio for sine 30 will be the opposite sides over the hyposides. So we can label the opposite as 1, to the hypo as 2. And then we can find the adjacent using Pythagoras theorem, which is just 2 squared minus 1 squared. And that gives you 2 squared minus 1 squared is 3. So that will give us the adjacent side to be square root 3. So from that diagram, we can actually find cosine 30, which is square root 3 over 2. And you see it's the exact in the sense that you don't see a lot of decimal places. It's just like one value, you know what I mean? And then tangent 30 is 1 over square root 3. From the same diagram, we can also find another angle that is 60 degrees. If you take 180 minus 90 minus 30, you get 60. And from the 60 degrees, we can also find the Trigo ratio for sine 60, that's it, which is cosine 60 first, which is A over H. So this case here, if your 60 degrees is your target, then your adjacent side is 1, and then the hypo is always 2. So that will gives you half. And you can also find sine 60, which is the opposite side. Now the side that's opposite to 60 will be square root 3 now. Right, and the hypo again is always 2. And we can also find tangent 60, that is square root 3 over 1, that gives you square root 3. Right, so these are the Trigo ratio for the special angle 30, 45, and 60. And from this simple activity, we can actually find some connections between sine and cosine. You'll see that sine theta is actually the answer for cosine bracket 90 minus theta. Meaning sine 30 is the same value as cos 60, right? Both of them gives you half. So likewise, cosine theta has the same value as sine bracket 90 minus theta. Right, meaning cosine 30 is equals to sine 90 minus 30 is 60, right? So cosine 30 is the same value as sine 60. And tangent theta will be 1 over tangent bracket 90 minus theta. And also for the other way round. So the next slide will look at the special angle 45 degrees. Right, so for 45 degrees, we will rely on tangent 45. Because if you look at the calculator, if you use the calculator, the tangent 45 will give you 1. So we can use that to find the Trigo ratio, the sine 45 and cosine 45. So likewise, we start off by drawing the right angle triangle, start off by having 45 degrees, and that will be isosceles triangle. And the hypo, you can find it by using Pythagoras theorem, which will be square root 1 squared plus 1 squared, and that gives you square root 2. Explain to the answer there. And from that triangle, we can find sine 45, which is 1 over square root 2. So we're going to rationalize it to get square root 2 over 2. And cosine 45 will be equal to sine 45 as what we have learned in the earlier slide. So that will also be square root 2 over 2. Okay, so understanding how this Trigo ratio of the special angles comes about, it's easy. The difficult part is how to memorize these values. So I'm going to provide you with 3 different ways. Of course, one of them is just to memorize it, but it takes time, right? It takes time to memorize something. So I'm providing you with 2 other quicker methods, okay, to find the values of this Trigo ratio of the special angles. Right, so if you were to examine the answer, you will see that the answers can be half, can be square root 2 over 2, square root 3 over 1, square root 3 over 2, or square root 3 over 3, right? It's one of these answers. Right, so you basically, yes, you still have to do some memory work lah. You still have to know that it's a combinations, it's a combinations of this number. So what you're going to do is that, supposing I want to find tangent 30. So you use your calculator, you press tangent 30, right? And on your calculator screen, you'll see 0.577350269. And then you try to match that number with one of those that I've listed here. So obviously it cannot be half, right? Right, so you try using square root 2 over 2. So on your calculator, you press square root 2, and then you divide by 2. Oh, it gives you 0.707. So then you know that this is not the one. And then you try again square root 3. You get 1.732, blah, blah, blah. So again, it's not what you want. And then you try square root 3, divide by 2. You get 0.866, blah, blah, blah. Again, it's not what you want. And then you try square root 3, divide by 3, and bingo! Yes, this one will give you 0.57735, so on and so forth. So this is the value for your cosine, for your tangent 30. So this is one way to do it, but you still have to remember that the answers for this ratio, the Trigo ratio of this special angles, is the combinations of all these numbers I've just shown you, right? Then another way, probably it's easier, is just to rely on your calculator. What it means is that, supposing you press cosine 30, and then on your calculator you actually see 0.866, 0.25, so on and so forth, right? So what we're going to do is that we're going to square the value you see on the calculator by pressing the x to the power of 2. On the calculator, you'll see that you will have a symbol for squaring it, which is x to the power of 2. So you press that, means you actually square your answer. And then when you square your answer on your calculator, now you should see 3/4. But however, 3/4, it's the value for square of cosine 30. We're not finding square of cosine 30, we're finding cosine 30. Therefore, I need to square root my 3/4. So when I do that, I can just apply the rules of surds. Will give you square root 3 over square root 4, and square root 4 is 2. So therefore, the answer for cosine 30 is square root 3 over 2. So this one could be an easier method for some people, right? So let's try again. Supposing you want to find sine 45, then on the calculator you see 0.707106, so on and so forth, which is irrational number, right? So you're going to square this value that you see on the calculator by pressing the x to the power of 2 on your calculator. So you square the answer you see on your calculator, and now you'll get half. You'll see half on your calculator screen now. So as explained before, we're not finding square root of sine 45, we're finding sine 45. So I need to square root to half. So square root of half, so you apply the rules of surds again. So square root 1 will gives you 1, and then you rationalize it, and that gives you square root 2 over 2. So this is another way of finding the values of your trigo ratio of these special angles. So you see which method you prefer. Alright, let's put what we have learned into practice. Let's look at question 1. Without using a calculator, we're supposed to evaluate tangent pi over 4 plus tangent pi over 6 times tangent pi over 3. So there are two things here. When you say without using the calculator, it means you have to show your working, meaning you're not supposed just to give me one answer kind of thing, right? You have to show your working. Then the second thing is that I think it's easier to manage questions in where the angles is in degree. So we're going to convert pi over 4 into degree. So therefore, we need to know the connections between pi and degree, right? Right, so we've learned earlier on that pi is equals to 180 degrees. So therefore, pi over 4, tangent pi over 4 will be tangent 180 divided by 4, that gives you tangent 45. And tangent 45, if you use a calculator, is just 1. So that's easy. Right, so let's go on to find tangent pi over 6, which is tangent 30 degrees. So this one, it's a bit troublesome, because if you were to use a calculator, you press tangent 30, it comes up to be an irrational number, which is 0.577, so on and so forth. But we know that tangent 30 degrees will give us an exact value. So we need to know how to convert whatever we see on the calculator into an exact value, right? So remember the earlier slides that I have taught you to square this value by pressing the x to the power of 2 on the calculator. So what you see is that when you press x to the power of 2 on the calculator, you will see on the screen answer squared. So you press equal and you get 1/3. Right, but we are not finding, the 1/3 is not the answer, because 1/3 is the answer for square of tangent 30. We are finding tangent 30, we're not finding square of tangent 30, we're finding tangent 30, therefore I need to square root 1/3. Right, so square root 1/3 will be square root 1 over square root 3. Of course, square root 1 is 1, so they give us 1 over square root 3, and we rationalize it. Rationalize it as you just multiply by square root 3 at the numerator, square root 3 at the denominator. You will get square root 3 over 3, because square root 3 times square root 3 gives you 3. So that's how we find the values for tangent pi over 6. So we're going to do it also for tangent pi over 3, that's tangent 60. Right, use the same method as what I've explained just now. You will get 3 tangent 60, you will get not 3, sorry, tangent 60, you will get 1.732 blah blah blah. So I need to press the x squared on the calculator to get 3. But I need to square root it, right? Because 3 is the answer for square of tangent 60. So tangent 60 will be square root 3. Okay, so with all these values, I'm going to plug into the question. Right. And then I can simplify this one here, where I will get Yes, 3 over 3, because square root 3 times square root 3 gives you 3. You just multiply the numerator, multiply the denominator. So square root 3 times square root 3 gives you 3 here. And 3 times 3 gives you 3 also. So therefore, 1 plus 3 over 3 will just give you 2 as the answer. So that's how you solve this question without using the calculator. Because you have just, shown all the steps here. So you've satisfied the requirement needed. Okay, so this one, for 1C, you're given angles in degrees, so that makes our life easier. So sine 60, so we're going to use the same method as what we've done when we solved 1A and 1B. You just use a calculator, plug in sine 60, and what you see on the calculator is 0.866025, so on and so forth. So we're going to square it to get a rational number, which is 3/4. But remember, we are not finding the square of sine 60. We're finding sine 60. Hence, whatever you see on your calculator, you just need to square root it. Okay, so you need to square root your 3/4. So that will give you square root 3 over square root 4. And square root 4, it's 2. So that will give you square root 3 over 2. Right, so cosine 45, do the same for cosine 45. Do the same method. Alright, you will get again the irrational number 0.707, so on and so forth. So you just square it to get half. So I need to square root your half. So square root half will be square root 1 over square root 2. So that gives you 1 over square root 2, and let's rationalize it. And you'll get square root 2 over 2. Do the same for tangent 30. Okay, square it. You get 1/3. So we need to square root 1/3. And that gives you square root 1 over square root 3. Gives you 1 over square root 3. Rationalize it. That gives you square root 3 over 3. Alright, so I'm going to simplify this by making it as a single fraction. So that will be 6. So I need to multiply a 3 to the square root 2, multiply a 2 to the square root 3. Okay, so I'm going to apply a neat method here. This is very, very useful. Okay, basically I'm going to make the denominator a non-fraction. So if you look at it here, the denominator of your denominator sorry, is 6. So I'm just going to multiply with the 6 here and also add the 6 on top. And so let's see what happened on top. At the numerator, sorry, not on top. Oh my god. Okay, let's see what happened. Right, so this will give me 2 times, this will give me 6 divided by 2 gives you 3. So 3 square root 3, right? Then over, right, you just write 6 as 6 over 1. So you're basically 6 divided by 6 will be 1. So you're left with 3 square root 2 plus 2 square root 3. Okay, so this is not considered simplified. Alright, it's not considered simplified because you can't actually have your denominator insert. So we need to rationalize it. So to rationalize it, I need to multiply with the conjugate sets. I hope you remember what conjugate sets are all about. So I need to multiply with 3 square root. Let's use a different color to show you the conjugate sets. 3 square root 2 minus 2 square root 3 over 3 square root 2 minus 2 square root 3. Okay, and so that's this one here. When you take this multiply by this, you will definitely get the rational number. So you can just use a calculator to work it out. So 3 square root 2 plus 2 square root 3 multiply with 3 square root 2 minus 2 square root 3. And you see on the calculator 6. Your numerator you can't, okay, you can't because you won't get a rational number. So for the numerator, basically you just have to use a distributive law and do it. So that will give you 3 times 3, 9. Then square root 3 times square root 2 will give you square root 6. Minus, for the other one, 3 times 2, 6. Square root 3 times square root 3 will be 3. So the answer you get to will be 9 square root 6 minus 18 over 6. In the pyramid, we can simplify further. I can actually factorize the common factor 3. We get 3 square root 6 minus 6 over 2. Okay, so this is how you do it for 1C. Right, let's look at question 20. Question 20, it's a very popular kind of exam questions. Right, you're given the diagram, shows a triangle ABC in which AB is 8 centimeter, angle ABC is 150. You're given AP is the height of the triangle, and you're given some ratio that it's BC is 3/4 BP. Okay, so we asked part 1 to find the exact length of BP. Right, so you see that we can actually find angle ABP, that's taking 180 minus 150, right, to give it 30 degrees. And we can also use triangle ABP because that is a right angle triangle. And right angle triangle, you can just apply your Trigo ratio, your Torcaso. Alright, so I can use sine rule because sine 30 is half. Of course, if you want to use cosine 30, also no problem. Right, but I think sine, and you can't use tangent 30, sorry, because tangent is opposite over hypo. Right, you don't know the value of your AP, you don't know PB, so you can't use tangent 30. You can use sine 30 or cosine 30, it's up to you. But I'm going to use sine 30 because sine 30 gives me half. So from there, I can find the values of AP to be 4 centimeter. And after that, I will use Pythagoras theorem to find PB. So maybe using cosine 30 is easier lah. Cosine 30 is just one stop. You can find your PB already. Okay, I'm going to show you later on, okay, using cosine 30. Alright. So from there, after finding AP to be 4 centimeter, you can use Pythagoras theorem to find BP. Okay, which turned out to be 4 square root 3. Because BP, if you use Pythagoras theorem, is just 8 squared minus 4 squared. Square root of 8 squared minus 4 squared. So 8 squared is 64. 4 squared is 16. 64 minus 16 is 48. So square root 48. And then I need to express it in simplest form. So 48 is just 16 times 3. You need a perfect square there. 16 is a perfect square. So square root 16 will give you 4. So 4 square root 13. But if you're going to use cosine 30, you'll find that you can do away with the Pythagoras theorem. So cosine 30 will be A over H, right? Which is your PB over 8. So therefore PB will be, do a cross multiply, PB times 1 is PB, 8 times cosine 30. And cosine 30, it's square root 3 over 2. Right? So that will gives you 4 square root 3, which is the same answer as what we managed to find earlier on. Right, so you can use sine 30 or cosine 30, up to you. Alright, the next thing is that I need to find, once I know BP, it's 4 square root 3, I will have to use the ratio, right? You can see that PC is equals to PB plus BC. Oh, sorry, I can just simply use the ratio that's given. The ratio that's given to us, it's BC equals to 3/4 BP. So I found BP to be 4 square root 3, right? So it's just 3/4 times 4 square root 3. Write it as a fraction so that it can just multiply numerator, multiply denominator, and that gives you 3 square root 3 for BC. Right, and of course PC it's equals to B. Oh my god, all the P and the B in mind. Can't they just use some other letter? Okay, never mind. So PC, it's basically PB plus BC. Okay, PB plus BC gives you PC. So PB, it's 4 square root 3. And then BC is 3 square root 3. So PC is just 7 square root 3. Okay. Oh my god. Oh, that is part 2. I've already found BP here. That is part 1. Okay, I found part 1 already here. Okay, so I'm actually doing part 2 now. Okay, right. So the next thing is I found PC already. So the triangle I'll be using will be APC because I need to find the angle ACB. The angle ACB here is the same as angle ACP because PBC is a straight line. Okay, so I can go on to find angle ACP using tangent. I have to use tangent now because I know the value for AP to be 4. I know the value of PC to be 7 square root 3. So I can use tangent. So tangent angle ACP will be AP over PC, which is 4 over 7 square root 3. So angle ACP will be tangent inverse 4 over 7 square root 3. And can you see that these two values will be the same? Because you're talking about the same angle, right? ACP here, ACB is the same as ACP. So therefore this value is the same as this value. Right, and therefore A square root 3 is equals to 4 over 7 square root 3. Okay, so we do a cross multiply. So A square root 3 times 7 square root 3 will gives you 4. So square root 3 times 7 times square root 3 will gives you 21 because square root 3 times square root 3 is 3, right? Then 3 times 7 gives you 21. So 21k is 4, so k will be 4 over 21. Right, so that's how you find the values of k in part 2. Okay, right, the letter A is to congratulate you because trigonometric function is actually not an easy topic. So if you have still been with me so far, I think you deserve an A. Right, so the next thing what we're going to do is we're going to do a recap on our Tuakaso, on our trigo ratio. So our trigo ratios, yes, we're going to continue with our unit circle in the first quadrant, right? So from that, you can find tangent alpha, which is just opposite over the adjacent side, which is 12 over 5. Okay, 12 over 5 is just an example. I can use other ratio also, such as 3, 4, 5. You know the Pythagorean triplets. You can use 3, 4, 5, or you can use some other Pythagorean triplets. Okay, So I'm just using this as an example. The values that I use there, 12, 5, 13 is just an example. So from there, I can find tangent alpha, which is opposite over adjacent side, give it 12 over 5, right? We can also find cosine to be 5 over 13. We can also find sine alpha to be 12 over 13, right? So this is what we learned earlier, the Trigo ratio of an acute angle. You see the alpha is a cube angle, and the cube angle is the angle that's between 0 to 90, right? So we're dealing with the first quadrant. All right, so all these values will be positive, you see? All the values, 12 over 5, 12 over 13, 5 over 13, they're all positive values. Okay, anything that happened in the first quadrant, the Trigo ratio will be a positive values. All right, so we are not actually just satisfied in staying at the first quadrant. You know, you just take the unit circle like a world. You would like to travel around the world to go other parts of the world, right? You're not just going to be contented just staying in, in one quadrant, right? So we're going to extend it to a second quadrant, and then let's see what happens. So now if you are traveling on the second quadrant, right, do you recall that when you measure angle in an anti-clockwise, it's a positive angle? So now the angle that you make with the x-axis will be the angle theta. It's an obtuse angle. Okay, it's an obtuse angle. When you go to the second quadrant, what you're getting is an obtuse angle. So do you think the Trigo ratio of an obtuse angle will still remain positive? Let's see what happened. So tangent theta will be opposite over adjacent. Your opposite side now it's 12 because it's above the x-axis. Above x-axis is 12 positive. But however, the adjacent side, if you look at the adjacent side, if you were to recall, when you label your coordinate, your Cartesian plane, right, on this will be all positive values, right? And the other side, when you label it, when you label your origin 0 and then 1, 2, 3, 4, 5, the kind of, and then the other side is -1, -2, -3, so on and so forth. So on the other sides of your origin is negative, so therefore you have to label this as -5. All right. The hypo is actually, if you look at the diagram, the hypo, it's the radius of the circle, and the radius of the circle is always positive. So your hypo is always positive. So 13 is a positive value. So therefore, tangent theta is 12 over -5. That gives you -12 over 5. So we're going to extend it to cosine theta. So cosine theta will also give you a negative value. Cosine is adjacent over hypo, right? That's -5 over 13, which is a negative value. How about sine theta? Sine is opposite over hypo, so that gives you a positive value. Right, so in the second quadrant, right, tangent of the angle theta, obtuse angle, it's negative. Cosine of the obtuse angle is negative. Only sine of the obtuse angle is still positive. Yes, so sine, it's still positive there. Okay, so what happened now that let's move on to the third quadrant. So you're not satisfied just to remain in the second quadrant, right? You just want to travel to some more countries. So now we go on to the third quadrant. So now your angle theta, it's more than 180, less than 270. Okay, and you see that the adjacent side is -5 because it's the other side of your x-axis, and then your height opposite is negative because it's below the x-axis, right? Below the x-axis, so it's -5. Your hypo, it's still 13 because that's the radius. The radius of a circle is always a positive value. So let's see what happened to your Trigo ratio. Do you think it's still the same as in the second quadrant? So let's see. So tangent, it's -12 over -5. So that gives you positive 12 over 5. Cosine will be -5 over 13. And then sine will be -12 over 13. So in the third quadrant, only your sine ratio is positive. Okay, so let's see what happens if you move on to the fourth quadrant. Right, and you see that tangent is negative, negative 12 over 5. Cosine will be 5 over 13. And sine will be negative. So therefore, in the fourth quadrant, cosine is positive. So that explains the ASTC that I mentioned earlier on. Earlier on, I mentioned about, in this video, we learned about finding reference angle, finding ASTCs. This is what I mean by ASTC. A refers to the first quadrant. So the trigo ratio of an acute angle in the first quadrant will be all positive. That's the reason why we give it A. And then in the second quadrant, only sine ratio is positive. Third quadrant, only tangent ratio is positive. Fourth quadrant, only cosine ratio is positive. Right, in the next few slides, we learned the importance of finding the reference angle and the objective of why we need to find the reference angle. Right, the reference angle is important to help us solve the trigo equation, especially when we need to find the angle which is not an acute angle. Right, if it's an acute angle, then it's pretty easy. You can just use the trigo ratio, the Trigo, to find the acute angle. However, when the angle, when the point P moves to the second quadrant and you're managing angle when it's an obtuse angle, or when you move it to the third quadrant, when it becomes an obtuse angle, you will realize that we need more skills, right, to find this angle. And how do we get to finding this angle? Depends on the reference angle that we're going to learn in the next few slides. Right, so this is just to give you an example of why we need to learn how to find the reference angle. Supposing you're asked to find sine theta equals to negative 0.5, negative 0.5, and the angle theta has to be between 0 degrees and 360 degrees. That means your angle theta has to be a positive value. So if you're going to use the elementary method you have learned earlier on, just to sine inverse negative 0.5, then you end up getting negative 30 degrees. But your negative 30 degrees does not fall within the range of 0 and 360. So therefore, we have to learn a new method. And that's the reason why this new method we're going to learn will need us to understand the concepts of finding the reference angle. So it is like a bridge that will take us to cross the river. Right, so if you look at the diagrams, there are 1, 2, 3, 4 diagrams, 4 diagrams there. We have learned that the positive angles are measured in an anti-clockwise direction. Right, so if you look at the first quadrant, if your angle is 45 degrees from the x-axis measured in anti-clockwise, meaning positive, then in the first quadrant, your alpha will just be 45 degrees. Alpha is the symbol to represent your reference angle. In some textbook, they used the word basic angle. Right, it refers to the same thing. So if the point theta goes to the second quadrant, right, theta is equals to 135 degrees, then the reference angle will be 180 minus 135 gives you 45 degrees. So the reference angle in the second quadrant will be the one shown here. Right, and then, okay, right, so when they travel to the third quadrant, then the reference angle will end up here, and that it's when you take 225 minus 180 to get 45 degrees. And if you travel all the way to the fourth quadrant, then your reference angle will be 360 minus 315, gives you 45 degrees. So from these four diagrams, you can see that the reference angle, it's the angle that makes with the x-axis. Okay, it's very important if you take notes of that. It's the angle that makes with the x-axis, and it is always a acute angle. It is an angle that's between 0 to 90. Okay, so that's a reference angle. We will learn how to make use of this reference angle, not to worry. Right, so let's look at what happened if your point P travels in the clockwise direction. In this case here, we're dealing with negative angles. Okay, so if you look at the first diagram, your theta is negative 45 degrees. Okay, you traveled in a clockwise direction. However, your alpha is 45. Your alpha remains at 45 because your alpha is an acute angle. It's a positive acute angle. It's a positive acute angle. Remember that. And it's an angle that makes with the x-axis. So look at the second diagram. Okay, your theta is negative 135 degrees, negative angle. However, your alpha will still remain at 45 degrees. Look at the third quadrant. Likewise, alpha is 45 degrees. And the fourth quadrant, alpha is 45 degrees. Okay, so in summary, the alpha is a positive acute angle that is between the line OP and the x-axis. Right, we're going to look at some examples on how we can actually find this reference angle. So let's look at the questions. The questions, you're given some angle there. In part A, you're given angle theta to be 100 degrees. And we need to determine which quadrant this 100 degrees lies in. And from there, we need to find the reference angle. So 100 degrees lies in the second quadrant. It is a positive angle, so you have to rotate it in a anti-clockwise direction. Right, so the reference angle will be that particular angle there, and we can find it by taking 180 minus 100. So 180 minus 100 will give you 80. So your reference angle here is 80 degrees. Right, the next one, theta equals to 285. So theta equals to 285. Which quadrants do you think it will end up with? Yes, you end up at the fourth quadrant. And therefore, the angle theta will be 360 minus 285. And that gives you 75 degrees. So therefore, your alpha will be there, right? And that is 75 degrees. Right, let's look at what happened when you're given a negative angle. So negative angle will have to measure in a clockwise direction. So negative 40, that will be a negative 40, right? But that is in the fourth quadrant, okay? If you were to recall the earlier slides we have learned, the first, second, third, fourth quadrants are fixed. Fixed as in, this is always the first quadrant, this is always the second, this is always the third, and this is always the fourth. For negative or positive angle, all right, the quadrants are fixed as such. So therefore, your negative 40 degrees will end up in the fourth quadrant, and the angle alpha is a positive acute angle. So therefore, alpha is 40 degrees. So for negative 115, you rotate it in a clockwise direction, you end up in the third quadrant. And your alpha will be the angle there, which is 180 minus 115, give you 65. Okay, let me repeat that your alpha, it's the reference angle, it's a positive acute angle mixed with the line OP and the x-axis. Okay, and the quadrant is always fixed as first, second, third, fourth in a anti-clockwise direction, regardless of positive or negative angle. Okay, let's look at the next two questions. We also need to be able to manage the angle given where the unit is in radian. But usually I'm more comfortable dealing with degrees, so I would change the one from radian to degree. So pi is equals to 180 degrees. So pi over 4 will be 45 degrees. And that happened to be in the first quadrant. So therefore, your reference angle is just pi over 4. Let's look at the second one. So negative 5 pi over 3 is negative 300 degrees. So if you measure the angle in a clockwise direction, you end up in the second quadrant. In the first quadrant, sorry, first quadrant. So your reference angle is 60 degrees. Right. So in summary, combining of what we have learned so far, using the Trigo to recognize the values of the Trigo ratio in different quadrants. In the first quadrant, all Trigo ratio will give you a positive values. In the second quadrant, only the sine ratio is positive. In the third quadrant, only the tangent ratio is positive. And in the fourth quadrant, only the cosine ratio is positive. And let's also summarize what we have learned just now for the reference angle. Okay, in the first quadrant, the reference angle will be that angle that makes with the x-axis and the line OP. Second quadrant will be the one that's highlighted in orange. The third quadrant is highlighted in red, and in the fourth quadrant highlighted in green. Okay, so how do we actually make use of this ASTC? So let's look at this question here. Let's look at 4a. All right, so we need to determine if the value for sine 278, is it going to be a positive value or negative value? And we need to determine which quadrant it is in. Okay, so let's start off by drawing your x and the y axis. So 278 is in the fourth quadrant. Right, so let's write down your ASTC. So in the fourth quadrant, only cosine ratio is a positive value. So therefore, your sine 28 is a negative value in the fourth quadrant. So to verify it, you can just use your calculator. Sine 278. It gives you negative 0.99, so on and so forth. Okay, so it's correct. Our answer is correct based on what we have learned earlier on using your ASTC. So let's go on to 4b. Cosine 132 is in the second quadrant. So who is positive in the second quadrant? Only sine is positive in the second quadrant. So therefore, cosine 132 is negative. So you can use a calculator again, press cosine 132. Yes, to verify your answer. Yes, and you get negative 0.669. So your answer is correct. Right, let's look at part C. Tangent 196. Tangent 196 is in the which quadrant? Oh my god, which quadrant? Third quadrant? Yes, third quadrant. So using your ASTC to guide you, only tangent is positive in the third quadrant. So therefore tangent 196 is positive. Yes. So now we are dealing with negative angle. So you measure negative angle in a clockwise direction. So negative 100 is in the third quadrant. So under your ASTC, in the third quadrant, only tangent is positive. So therefore sine bracket negative 100 is negative. Right, so let's continue. Let's convert. Let's do part E. Convert 13 pi over 8 into degree. So pi is 180 degrees. So that will be 13 times 180 divided by 8. That gives you cosine 292.5. So 292.5 is in the fourth quadrant. So again, you apply your ASTC. And cosine is positive in the fourth quadrant. So therefore, cosine 13 pi over 8 is positive. Okay, do the same for your tangent negative 2 pi over 2 negative 2 pi over 5. That will be tangent negative 72. First quadrant. So therefore tangent bracket negative 2 pi over 5 will be negative. Okay, let's look at the next question. The next questions are slightly, it's not difficult. Why not difficult? Because you're given cosine 35, which is an acute angle. So anything that's an acute angle, you don't have to worry about positive or negative, because if you were to recall, all the acute angles that happens in the first quadrant will have all the triple ratio positive. Okay, so let's go on to draw your right angle triangle in the first quadrant. Okay, label at 35 degrees. Okay, so cosine 35 degrees is equals to k. K is just a ratio, right? You can actually write it as k over 1. K divided by 1 gives you k. Because cosine 35 basically is just a ratio, right? So k, you can write it as k over 1. So k can represent the adjacent side and 1 represent your hypo. Okay. So I can label my adjacent as k, my hypo as 1. And then I can use the Pythagoras theorem to find the height of the triangle, which is just square root 1 squared minus k squared. That gives you square root of 1 minus k squared. So from there you can find tangent 35. And you can also find tangent 55. So where exactly is 55? Yes, that is your 55. If you take 180 minus 35 minus 90, that's your 55. So your tangent 55 will be k over square root 1 minus k squared. So we plug all this value into the questions. And we need to find the common denominator. Okay, so how do you end up getting 1? Because you will have to multiply k with 1 minus k squared, right? So you're basically multiplying this also with square root 1 minus k squared. So they're the same value, right? It's like square root a times square root a. Square root a times square root a will just give you a, right? So that will just give you 1 minus k squared. And then this one here, you must times k. So 1 minus k squared plus k squared. So what do you get in the end? Yes, you get 1 over k times square root 1 minus k squared. Okay, so it's always a blessing if the angle A given is in the first quadrant. But if you look at question 12, right, yes, it's not going to be that easy anymore. Your A is between 0 and 3 pi over 2. So 3 pi over 2, if you convert it into degree, it's 3 times 180 divided by 2, that is 270. That means your angle A can be in the first quadrant, or second quadrant, or third quadrant, because it's between 0 to 270. Between 0 to 270 can be first, second, or third quadrant. Right, if you were to draw your unit circle, this is 0 degree. This is 90, 180, 270, 360, right? So between 0 to 270 means can be in first, can be in second, can be in third quadrant, right? So now let's look at your sine A equals to negative 3/4. Sine A equals to negative 3/4. Remember your ASTC? Your sine ratio is only positive in first and second. So to get a negative ratio for sine, it has to be in third and fourth. Okay, it has to be in third and fourth. So we're going to do some matching. Yes. So from the first case, your angle A can be first, second, or third. From the second case, your angle A can be third or fourth. So if you compare these two results, then which one is the one that satisfies both? Yes, of course, it's in the third quadrant. So we need to draw the diagram in the third quadrant. So let's start off by, wow, beautiful circle. Let's start off by drawing the triangle in the third quadrant. So that will be your angle A, right? And we need to, so sine ratio is to take the opposite side over the hypo, right? Now the hypo, it's the radius of the circle that's always positive. Okay, so that means your hypo must be positive. So it's the value 4. So therefore the negative will go to your opposite sides. Right, and then we need to use Pythagoras theorem to find the one that's highlighted in pink. That's the adjacent side. And you see that the highlighted in pink, it's on the right hand side of your y-axis, which is a negative value. So you see that I have a negative value there. Here. Okay. So you use Pythagoras theorem, you'll get square root 7, but it's a negative square root 7 because it's the other side of your y-axis. Okay, so from there I can find my cosecant A. Cosecant A is actually 1 over sine A. You just look at the third letter. Third letter is the letter S, right? So 1 over sine A. So it's 1 divided by negative 3/4. That gives you negative 4/3. Right, then you need to go on to find secant A. The secant A, the third letter is C, so 1 over cos A. Okay, and then also rationalize it. Yep. And then cotangent A is 1 over tangent A. Right. And you will get square root 7 over 3. It makes sense because tangent is positive in the third quadrant. Cosine and sine are both negative in the third quadrant. Okay, so to remember cosecant A, you just look at the third letter. The third letter is the letter S right here. So it's 1 over sine A. Then secant A, if you look at the third letter, is a letter C, so 1 over cos A. Then this third letter here is T, right? So 1 over tangent A. Yeah. That's how you remember it. Right, so it's 12:15 on a Sunday morning. Right, so this will be the last questions. All right, so bear with it for a while. Okay, so we're given sine 20. Oh, I'm very happy every time I got sine 20 because it's a cube angle. So it's in the first quadrant. Trigo ratio of and the cube angle is always positive. So we're going to draw your beautiful triangle in the first quadrant. All right, so express in terms of k sine 200. So what is sine 200? Okay, before we do that, let's label your opposite and your hypo and your adjacent side for your sine 20. Alright, so use Pythagoras theorem. That will be square root 1 squared minus k squared. So that gives you square root 1 minus k squared. Okay, so let's look at part I now. Sine 200. Alright, so sine 200 actually happens to be in the third quadrant. So we need to express it as in terms of the reference angle. So the reference angle, if you were to remember, is the angle that makes with the x-axis. So in this case here, your reference angle is, yes, is the angle there, which is 200 minus 180. Gives you 20 degrees. So first thing is to find your reference angle. Second thing is to use your ASTC. Right. So your 200 degrees is actually happen in the third quadrant, which is only positive for tangent ratio. So therefore, for sine ratio is a negative value. So therefore, sine 200 degrees is negative sine 20. and sine 20 is given to be k. So therefore it's equals to negative k. Okay? Right. So for part 2, cosine 70 degrees. Yes, we learned in the earlier slide that cosine 70 is sine 90 minus 70. Cosine 70 is the same value as sine 20. So sine 20 is k. So cosine 70 is equals to k. Supposing if you cannot remember the connection, there's another way to find 70 degrees also. If you go back to your beautiful right angle triangle, this one is your 70 degrees. Right, so cosine 70, it's ka a over h, so it's k over 1. That gives you k also. That's another way of finding, okay, cosine 70. Right, let's look at part 3. Okay, we have to draw the diagram again. Right, so negative 20 degrees, it's a negative angle, so you have to measure in a clockwise direction. So your reference angle is 20. So under ASTC, only cosine is positive in the 4th quadrant. So tangent bracket negative 20 degrees is equals to negative tangent 20. Right, so from the diagram, tangent 20 is just k over square root 1 minus k squared. Alright, so part 4, secant 160. Okay, so if you look at the third letter of the secant, is C, so it's 1 over cos 160. So we're going to draw the diagram again. 160, it's in the 2nd quadrant. So your reference angle is 20 degrees. And it's equals to negative because your cosine ratio is negative in the 2nd quadrant. So that is equals to 1 over negative cosine 20. And cosine 20, it's square root 1 minus k squared. So 1 divided by negative. Oh, I should put it the other way around. Okay, never mind. I should put, yeah, it's correct. I should put the negative in the middle lah. Doesn't matter lah. Okay, so 1 divided by negative 1 minus k squared will just give you negative 1 over square root 1 minus k squared. Okay, right, so that's complete this video on trigonometric functions. Okay, right, thank you.